Okay, so in this video we're going to multiply and divide binomials with radicals in them. So, for example, if I have 3 minus the square root of 2 multiplied by 4 plus the square root of 3, and I'm just going to FOIL those two binomials. So 3 times 4 is 12. 3 times radical 3 is 3 radical 3. Negative radical 2 times 4 is negative 4 radical 2. Radical 2 times radical 3 is negative radical 6. And now I'm just going to try to simplify anything that I can, which I have no like terms. I have no radicals, radicands that are the same in this expression, so this has just been simplified. So I can list those 4 terms in any order, and that would just be fine. We'll try another like that. That cleans up a little nicer. 3 plus radical 2 times 3 minus radical 2. FOIL again. Should be 9 minus 3 square root of 2 plus 3 square root of 2 minus the square root of 4. So I have 9. These two terms are going to cancel, and the square root of 4 is 2. So 9 minus 2 is 7. So this is a convenient phenomenon that we notice when you multiply. Anytime you multiply a binomial expression with a radical in it by the same expression with a different sign in between, called the conjugate, we're going to end up eliminating all of our radicals, and we'll end up with a final answer that is just some rational number. So, really nice thing to notice is that if we have an expression with a radical in it and we want to get rid of that expression, we should multiply by the conjugate. Now that's important because let's say we have 4 over 2 minus the square root of 3. Well, we know that we don't like there to be a radical in our denominator. So we have to try to find a way to get rid of that. Well, looking at what we just did, we know that if we multiply it by its conjugate, we're going to end up with a rational expression. And that's what we want in the denominator. So in the numerator, I'm going to distribute 8 plus 4 radical 3. In the denominator, I'll get 3 plus 2 radical 3 minus 2 radical 3 minus the square root of 9, which gives us 8 plus 4 square roots of 3 over 2 minus 3, which gives us 8 plus 4 square roots of 3 over negative 1. Well, if I'm dividing everything by negative 1, I can just change all of the signs and make it negative 8 minus 4 square roots of 3. So that is a way that I could write that expression. We'll try one more example like that. 3 minus the square root of 5 over 2 plus the square root of 3. Okay, again I have that radical in my denominator, so I need to try to eliminate that. So I'm going to multiply by 2 minus radical 3 over 2 minus radical 3. So my numerator is going to be 6 minus 2 radical 5 minus 3 radical 3 plus the square root of 15. My denominator is going to be 4 plus 2 radical 3 minus 2 radical 3 minus the square root of 9. So I get 6 minus 2 radical 5 minus 3 radical 3 plus radical 15 all over 4 minus 3, and 4 minus 3 is just 1. So my final answer turns into the expression that's in the numerator. So that would be my answer, and that's how you rationalize your denominator.